I want a proper graph here, which means it needs all the things a graph needs. Scales, titles, input, output, a line if it's continuous, dots if it's discrete. Go. Talk to your neighbor if you need to. What did you decide was the independent variable? First of all, what are the two things that are changing? What are the two variables? Cost and number of toppings. Which one is independent? Toppings. Where does the first dot go? There's always a giant argument here. At 12, does it go over here at 0? Yes, because cheese does not count as a topping. Without cheese on a pizza, what you have is bread. All right. Now, at 1 topping, what does my dependent variable become? $13.50. At 2, what does it become? 15. At 3, what does it become? 16.50. At 4, what does it become? 18. And then we're going to stop because more than 4 toppings on a pizza is grody. Yeah. And those 4 toppings are pepperoni, ham, bacon, and hot peppers. End of discussion. Cheese doesn't count. Cheese is already there. Pineapple has no place on a pizza. No place on a pizza. No place on a pizza. The Hawaiians ruined pizza. The Californians helped by putting things like broccoli on it. Next question. Does this line exist? Of course not. Why? You cannot put on half a topping. You can put topping on half the pizza, but they still charge you for it. Everybody good? Every single one of you should have been able to graph that properly by now. This is a pictorial. This is a pictorial representation of a linear relation. Now, this happens to be a linear function as well, yes? Because if we do the vertical line test, it only hits in one spot, correct? Everybody with me? All right. So that is a pictorial representation. Now, in this blank space right here, we're going to talk about what that is. A linear relation is a function in which the dv and iv change at the same rate for the entire domain and range. So, if it changes at the same rate, that means that no matter what happens to the domain, the range will change by a proportionate amount. Everybody understand? Here is what I'll let Aiden talk first, then I'll talk. Go, Aiden.
So if you do it with a line,
it would be a nice flat straight line. Well, not flat, a nice straight line. Here is what I mean. How far did I go this way on my domain right here? From there to there. 1. How far did I go there? 1.5. Everybody agree? Now, if it's a linear relation, if I go this way 1, I'm going to go this way 1.5. Did I? Yes. If I go this way 2, then I'm going to go up 3. Did I? If I go this way 3, then I'm going to go up 4.5. Is everybody good? A linear relation makes this staircase effect. But, and I'm writing this in red, danger, Will Robinson, danger. It does not need to be continuous. You don't need the line to make it a linear relation. Is everybody good? As long as the rate of change is always the same, it's still a linear relation, whether it is discrete or continuous. Everybody okay? All right. You all can easily see on a graph when something is linear, right? You go over 1, up 1.5, you do that a couple times, it's a line, right? You also know how to do this with a table of values. You learned this in grade 9, except your table of values were X and Y. What have they become in grade 10? It's not X and Y, what is it? IV and DV, right? Everybody cool? Now, if it's a linear relation, 5, 7, 6, 10, 7, what's this number going to be? 13. Why? Because it goes up by 1, so this is going up by 3, so that's going to continue. Okay? What is this going to be? Now what's that number going to be? $19. Why? It's not 19. What is it? 22. Thank you. You need one more. Why? Because you're going up by 3 for every 1. Everybody understand? Yeah? All right. This you learned in grade 9. This you might have touched on in grade 9. If you were in my grade 9 class, you did this part to death. All right? An equation of a linear relation always looks like this. Dependent variable equals the independent variable with some math. Always. All right? So you learned in grade 9, dependent variables were y, independent variables were x, and then you did some math to the x, right? Let's say you did this, 2x plus 3. So in grade 9, which of these is input, x or y? X. So you input the numbers. You choose what numbers go here. Everybody with me? So somebody give me a number. 3. Great. X is 3. So what goes there, Evan? X is 3. So what do I write right there? 3. So y would equal 2 times 3 plus 3. What is 2 times 3? Plus 3? 9. So y would be 9. Right? What if I then used 4? What would it be? It would be 12, correct? 2 times 4 is 8. 8, 11. You're killing me, Ayaka. 11. Now, you're smart kids. That's a linear relation. So if I put 5 here, what's this automatically going to be without even doing math? 13, because I added 2 each time. Everybody good? In grade 10, this becomes IVDV, right? So on the graph we just made, we said the IV was toppings and the DV was cost, correct? When I had 0 toppings, what was my cost? 12. When I had 1 topping, what was my cost? $13.50. When I had 2 toppings, what was my cost? $15. Agreed? And that will go on, won't it? Now, I want an equation that will tell me the cost of this pizza at any given moment. Every equation is dV equals IV in math, correct? So, what was our dV? Toppings or cost? Cost. So cost of this pizza will always equal my IV. What is my IV? Toppings with some math, correct? Well, let's check. What's happening right here? What did I do to get from that to that? I added $1.50, correct? Everyone agree? Okay. What did I do there? I added another $1.50, didn't I? What would I do at the next one? Add another $1.50 at the next one. Add another $1.50. Do math guys like to write plus 150, plus 150, plus 150? What is math's shortcut to repeated addition? Multiplying, right? So I know I got to multiply my cost by $1.50, don't I? Right? So this toppings is going to get multiplied by 1.5, yes? Everybody with me? All right. Let's check if that works. My IV is 0. My IV is toppings, correct? What happens if I put 0 in for T right here? What's 1.5 times 0? 0. Do I get the pizza for free if I don't put toppings on it? What's it cost me? $12. So I must have to add 12. Everybody agree? Now let's check if that works. When I have 1 topping, what goes in for T? 1. What's 1.5 times 1? 1. What's 1.5? What's 1.5 plus 12? 1350. Do I have the right equation? What is it? Cost equals 1.5 times T plus 12. Now, if I want 5 toppings on my pizza, how much is pizza going to cost me? It's tough to do 1.5 times 5. It wasn't nice of me. What is it? 1950. Everybody cool? Here's what you do. This number multiplies your IV. Then you do the adjustments needed. Everybody cool? All right, so linear relations. There's 4 ways. 1, you can graph it. 2, you can have a table of values. Some of you call those tables of values T-charts. They're the same thing. 3, you can have an equation. 4, you can have words. You can now do all 4 of them. What is the thing that's the same in all of them? The rate of change is what? Now, it's weird to talk about change being constant, isn't it? Because constant means something doesn't change. But we're talking about a rate of change here being constant, which means if my IV goes that far, my dV goes that far, and that would continue. This distance would be the same there as it is there. And this distance would be the same there as it is there. Does everyone understand linear relations? Do you need to actually draw the line? No. If the dots make the steps, you have a linear relation. It's just a discrete linear relation. Gouda? Great. Turn the page over. Now, I think your guys printed badly here on page 158, or do you have the 2 charts nice and separate?
Yeah.
You have them separate? Great. Is the first one linear? Yes or no? How do we check? Which of these is the IV? Over here. We always put IV over here. We always put dV there. So if it's linear, if this changes, how much did this change by? 5, and then there? 5, and then there? 5. So if it's linear, all these changes will be the same, won't they? Are they? What's that? 9. 9. 9. Is it linear?
Yes.
Yes. Can you figure out the equation? It's tricky. I told you this number has to go over here, right? What letter would you use for IV? Because we don't want to use X and Y. What letter are we going to use? C. And what letter would we use here? F. Okay. So the 9 has to go with the independent variable, right? So Fahrenheit must equal 9 Celsius, correct? Let's check, see if that works. What's my C here? 0, so I put 0 there, correct? But I need an output of 32. So what would I need to do here to make this first line work? I'd have to add 32, correct? See if that works on the next line. Hello. Oh, okay. That was nice where I was going to pick it up at her school, but okay, thank you. Yep, thanks. Hey, back. Did that work for the next line? What's C now? Just, what is C now? So what would go here? If C is 5, what would go there? 5. Would be 9 times 5 is 45 plus 32. Does that work? No. So what's happening that has changed our pattern? Celsius is not going up by 1, is it? It's going up by 5, correct? Let's check. If the 9 goes to here, where do you think the 5 goes? The 9 went over to the IV. Where do you think the 5 goes? Over to the dV. So this must have a 5. Are we okay? Everybody cool? Is this a good representation? Does this one work? Does it? What's my number? What's my degree there? What is C right there? 0. So what would go there? 0. 0 plus 32 is 32. But this is supposed to be 32. So that's not going to work, is it? So what do I got to do? None of this is working. So what do I got to do? Aiden has already touched upon it. What made this one weird? It's because these are going up by 5, right? In our previous example, they went up by 1, didn't they? So we need to know what would happen if it went up by 1, correct? So if this is going up by 5 and this is going up by 9, if this is going up by 1, what math am I doing to that to find out what 1 is? Subtracting 4? Dividing by 5, correct? So if this goes up by 1, this must go up by 9 divided by 5. Agreed? Does everybody understand that? I'm going to wait a second because this is kind of important. Does everybody understand what I just did there? When I went up by 5, I went up by 9. So if I go up by 1, that's my 5 divided by 5, correct? So that must mean this is dividing by 5. Does everybody see that? Now, let's check. Let's take our 9/5 and put it here. So I now have 9 over 5 C plus 32 equals Fahrenheit. Let's check. What's my Celsius right now? 0. What's 9/5 times 0? 0 is 0 plus 32, 32. We're happy, right? Okay. Let's check this one. Now my C is what? 5. So 5 would go here, correct? What would happen if I put 5 here? What is 9/5 times 5? What happens to the 5s?
Cancel.
They cancel. So now I have 9 plus 32. Is that 41? Yes. Do we now have the answer?
Yeah.
So now we have our equation. Is everybody good? Okay. What about this one? What am I going up by here? 5. What am I going up by here? So is this one linear?
No.
No. So I can't even make an equation for it. Everybody good? What about this one? I've given you the equation. Do you know if it's linear? Some of you do by looking at it right away. The only way to prove it, though, is to make the chart. Who decides what the x numbers are that we put in here? You do, because they're input. So give me 3 numbers. 1, 2, 3. Now I'm going up by 1, yes? When x is 1, what's y? 6. Does everybody understand why y is 6? Okay, what's 2? 8. What's 3?
10.
10. Is it linear?
Yeah.
Why do you know that? Plus 1, plus 2. Plus 1, plus 2. I know that you're busy texting this incredible knowledge to all your friends. I know that. But just tell them to go on my YouTube link and they can get it there, okay? Then you two could actually pay attention to what's going on instead of your phone. And I wouldn't have to be a dick and take it away. Okay? What about the next one? This one is linear. Great. What about this one? Yes or no?
No.
The only way to do it is to check. We'll use 1, 2, 3. That's 3. That's what? 15, and that's what? 30, 36, 36, 35. Is that linear? No. Please notice what is the only difference between that and that? The squared. Exponents in an equation make it non-linear automatically. Why? Because every time you change your x, your number doesn't double or triple, it exponent, right? So it goes from 1 squared to 1, 2 squared to 4, 3 squared to 9, 4 squared to 16. See what I'm saying? Now we have graphs. Is that linear?
Yeah.
Choose a point and check it. I went down 1 and over, what would you say that is? About 2/3? Let's check it here. Is this distance, is the blue distance and the red distance the same now? They went up and down 1, correct? Is the blue distance and the red distance the same there?
Yeah.
Sure looks like it. So this one is linear. This one always causes problems. Yes or no? Is that a line?
Yeah.
Yes. So is it linear? Yes. When x is 1, what's y? 2. Agreed? When x is 2, what's y? 2. When x is 3, what's y? 2. That's going up plus 1. It's always the same, correct? What's this one doing? Plus 0. Is it always the same? So is it a line?
Yeah.
Yes. What about f? Yes or no?
No.
No. Easy peasy. What about g?
Yeah.
Yes. All right, the last thing you need to do for me, and this is starting to lead us directly into our next unit, because as you can see, there's only one more lesson for this unit, so we start thinking about next unit. Make a table of values and graph. Who decides what goes in for x and y? You do. Does it matter what numbers you use?
No.
No. Any numbers. I always like to use at least 3. Can anybody tell me why I need 3? Why isn't 2 enough?
To make the line.
Pardon me, Michael? Yes. I could connect any 2 lines with a straight line, couldn't I? But until I put in a third, I don't know if that change is the same. What if my third dot was way up here? Is that a linear relation? No. So choose 3 numbers. Now, everybody always gets stupid here when I say choose your 3 numbers. 17, 84, 121. Does that make sense with the graph I've given you?
No.
No. What are some good x values you could use? You choose. Whatever you're going to do. And then you're going to do the same thing over here. Remember, it's always good to choose a couple of negatives, 0, and a couple of positives. So you've all choose some numbers here. I'm going to use -2, -1, 0, 1, 2. That's what I almost always use. Now, for some reason, what I'm about to do when we get to the next unit becomes very confusing for my classes. I don't know why. I'm going to tell you exactly the same thing I tell every class. This -2 is where the x is, correct? Which means what number do I write where that x is? -2. What is 2 times -2? -4. What is -4 plus 4? 0. Okay? What is -1 times 2? -2. What is -2 plus 4? 2. What's 0 plus 4? 4. 6, 8. Is it linear? Why? What makes this linear? Every time my x goes up by 1, my y goes up by 2. Then I graph it. Again, for some reason, it's very confusing. I have given you an x and a y, which means we can write it as an ordered pair. -2, 0. For some reason, that is a complicated step. Is it complicated to any of you? All of you understand that this point of x -2, y 0 is this point on the graph. Great. What's the next point on the graph? -1, 2. What's the next point on the graph? 0, 1, 2, 3, 4. What's the next point on the graph? 1, 6. What's the next point on the graph? 2, 8. Do I connect the dots?
Yes.
Of course I do. Why? Because they're just numbers. Here is what I mean. What if I said x was 0.5? What would go there?
5.
0.5. What's 2 times 0.5? 1. What's 1 plus 4? 5. Let's check. When I go to 0.5, that's right there, yes? Halfway between. Let's go up. 1, 2, 3, 4, 5. Did I hit the line? That is why I connect the line. Because I can put any number in there, can't I? Because whatever number I put in, I can multiply it by 2, add 4, and get an output, yes? So when it's x and y, it's always connected, right? What if I change this to cost and kid? Would I connect the line? No. Because I can't have half a kid. Everybody understand? All right. This one, I'm going to use the same numbers. -2, -1, 0, 1, 2. What is -2 squared? 4. What is 4 minus 3? 1. What is -1 squared? +1. What's +1 take away 3? -2. What is 0 squared? 0. What is 0 take away 3? -3. What is 1 squared? 1. Take away what? 3. So it's -2. Wait a minute. What's 2 squared? 4. Take away 3? 1. Look at what's happening. What's my first point? -2, 1. -2, 1. Okay, no problem. -1, -2. Okay, no problem. 0, -3. That makes a nice curve. But then look what happens on the other side. The same thing, and it makes a nice curve. That will go on forever. Is it linear? No, you already knew it wasn't linear. How? It had an exponent. This is what's called a parabola. You will see them to death in grade 11, no matter what math you choose. And you see them to death in physics. And in biology quite a bit, actually. You're going to see those a lot. Is everybody good? All right. Please notice this assignment looks gigantic. It goes all the way to page 163. But notice that it isn't that many questions because there's lots of pictures and there's lots of long paragraphs explaining the situation. It's not a lot of work. Tomorrow is quiz 1. Quiz 1 is on independent variable, dependent variable, domain, and range. Okay? Tomorrow is May what? 8th?
Yeah.
May 8th. Quiz 1. IV. DV.
Yeah.
Domain. Range. And everything to do with that. So is this a function or is it a relation? Because that matters to domain and range, right? Shut up! No way! And I didn't eat breakfast today because I had to make special breakfast for my kids because I forgot to buy them any lunch meat.
Keep going.
Score! Do math.
Yeah, well. Keep going. Where's my breakfast? Yeah, because back it up. Funny.
We don't have food, then like to share it. We don't have way more food than we do.
All of the movies, like all of their animals, all of them goats. Yes. Like go to like soccer players, and like go to like chick goats. It's chick goats.
Stay in school, kids. 6 years of university, you two can get free breakfast.
Once in a while.
Once in a while.
Once a year. Oh, that's delicious.
Want to share?
And it's gluten free, which makes it healthy for you, even though it's filled with chocolate and sugar. Ladies and gentlemen, that quiz is it's all multiple choice. I think it's 8 questions or 10 questions or something. We'll do it tomorrow. Kevin? You got this? Okay. I'm gonna eat my brownie then, because I don't think I could calmly respond to that question by the 4th unit. I feel I've maybe answered it once or twice.
You can always retake.
Where's your white shoe? Oh my god, there's a non-white
Okay.
Take a white from the inside.
I think the world needs to hear my students asking for the 27th time if they can retake a test.